So this whole next unit, we're going to talk about applications of integration to various different situations. Some of the things are going to be geometric, some things are going to be physics. And this unit spans 2 different chapters. Chapter 6 does come before Chapter 7, which means all the fancy integration techniques you won't need to use to solve problems in Chapter 6. Does that make sense? Unless I especially put them on the quiz, like the take-home quiz, I can kind of pull them from different sections. So, but at least the stuff in WebAssign, you shouldn't have to use stuff from Chapter 7 to do these integrations. And technically, if you took AP Calculus, this stuff was in AP Calculus. So, all right, so the first application is area between curves. So in Calculus 1, you learned how to find area under one curve, right? Yes? That's what a definite integral was. So what if you have 2 curves? Everybody got a packet? So x, y, and let's make, there's some curve y equals f of x, and some curve below it, y equals g of x. And I made that curve go negative on purpose. And we care about the area between them, between some a and some b. So does the general question idea make sense? That's what you want to find? Okay, so back in Calculus 1, when you didn't know how to find, you didn't know that an area under curve was an integral, you divided your thing up into boxes and you added up all the boxes, right? So let's just draw in a bunch of boxes and talk about how we might find this area. It's going to reduce to something pretty easy. Okay, so whatever, you have some boxes and their width is delta x. What is the height of every single box? It's really easy if you have a box where it's all above the x-axis. What would the height of that box be? Top minus bottom, yep, so f of x minus g of x. Now, does that still hold if your g is negative? Think about that. It does, doesn't it? Like supposing this distance was something like 7 and that was something like -2. If you do 7 minus -2, it gives you 9, right? So in that case, the height is f of x minus g of x every box, right? Does that make sense? So the area would be about equal to some kind of sum of f of x minus g of x times delta x. And technically there should be like little sub-i's on these things that mean like, first box, second box, third box, and your I goes from 1 to n. And then how do you make that area exact? What do? Technically you take a limit. Does that idea make sense? You take a limit as n goes to infinity of that thing, which makes it into an integral from left to right f of x minus g of x dx. But the idea that when you don't know how to do something, that you break into small chunks, figure out those chunks, add them all up, and limit the number of pieces to infinity, that's going to come up repeatedly in this unit, because that's how you do everything. Break it up, add the pieces up, take a limit, which makes it an integral. Okay? That's where all the formulas we're going to use are going to come from, for example. Now the kicker here is that the order of these curves was actually important. Does that idea make sense as well? That f of x was the upper curve and g of x was the lower curve. So if you have 2 curves, the area between the curves is given by the integral that is the difference between the two, dx, that's it. And you can kind of think of this should make sense that that's, the area under f of x minus the area under g of x. That also makes sense, doesn't it? Yeah. Now, these questions are actually talking about area in the traditional sense. Will you ever get a negative number? No, you won't. And that's because this expression f of x minus g of x is supposed to be positive. right? Because you've taken the upper curve minus the lower curve, which ensures that this first number is always greater than that second number. Okay, so in this case, there's no negative areas. Yeah?
So what if they deliberately give you the lower curve and want you to...
You have to graph it and figure out which curve is on top. So the problems will not specify an ordering of the curves. It will say, here are the curves, figure out which one's the upper, figure out which one's the lower, and then set the integral up appropriately. Does that make sense? Yes?
What if they alternate?
That's a great question. That's on the next page. Okay? Do you understand that question? It's like, what if who's on top changes halfway through is your question, right?
Yeah, like what if there one's higher on different intervals?
Then you have to you have to do specialness, and we'll get there, okay? I promise. Okay, so first let's just do an easy one. How about y equals x squared and 2x minus x squared? So I gave you a grid so you can put the things through the right points. So what points does x squared go through?
The 0, 0.
Uh-huh.
Well, 1,
1, 1.
Negative 1, 1.
Uh-huh. 2, 4, right?
Yeah.
Okay. Okay, 2x minus x squared.
The vertex is 1, 1.
Yeah, so how'd you find that? So here's what I would say. When you are graphing a parabola, I think it's easy to look for the intercepts. Does that idea make sense? Like the x-intercepts and the y-intercepts. So if you set this equal to 0, take out the greatest common factor, you find x equals 0 and 2. What does that tell you about the graph of this parabola? Crosses the what axis? X at 0 and 2. And then, because you have a negative coefficient in front of the x squared, is it a right side up parabola or an upside down parabola? Upside down. I call those sad parabolas because they're like frowny faces. You know, negative, sad. Okay, sorry. And so then if you just plug in like some numbers, you know it goes through 1, 1, and it will look something like, you plug in negative 1, I think you get negative 3. Looks like this. Oh my gosh, I can't connect my dots. I should go back and fail elementary school. And you could verify this by graphing them. You should always make sure you can do algebra 2 like graphing of parabolas, but you can also like check and see if your graphs are right, like on your homework and stuff. Okay. Now when they say enclosed, they didn't tell us bounds, they just want to know what's the area in between them, the finite area, nothing infinite. So in your integral, what is the left bound? 0. Yep, so you put the x value, which is 0, and then the other bound is 1. And then who's your upper curve? 2s minus x squared minus the lower curve, which is x squared.
Can you simplify that?
Oh gosh, yeah, yes, and you definitely should. Before you anti-differentiate, it will be fastest if you combine like terms. Does that make sense? Yep. So this is the same thing as the integral from 0 to 1, 2x minus 2x squared. And once you've combined like terms, then anti-differentiate. That ensures you have fewer things to add once you get to plugging numbers in. So the antiderivative of 2x is x squared minus 0 to 1. So that gives us 1 minus 2/3 minus 0, which is 1/3. Does that answer make sense based on our picture? Yeah, because yeah, and it's also inside this little 1 by 1 box. Does that make sense?
Yeah.
Okay. If your points of intersection were not totally obvious from your graph, how would you find them?
Set them equal to each other.
Is it okay if I use POI for points of intersection? Boy. By solving x squared equals 2x minus. Like if it's completely obvious from your graph where they are, you don't have to do that also. Does that make sense? But if it's not obvious from your graph where they are, if you want to verify, you could also do that. Mm-hmm. Okay, so that one was nice because that parabola had nice x-intercepts, right? I think the next one does not have nice x-intercepts. So we'll have to do a little bit more fussing to make it work. Okay.
So do you complete the square?
Yeah, that's one way. Yep. Okay, so everybody can graph x plus 1, right? That's a line with y-intercept
Uh,
1. Yep. And slope 1. And I don't know about you, but you know, I can't connect the dots unless I have a lot of dots. I'm going to put a lot of dots and just connect them.
It's easy to create a lot of dots from that.
When I give you a grid, it's super easy to create a lot of dots, definitely. Okay, graphing that guy. Now, there are lots of ways to do this. You maybe were taught in an Algebra 2 class to use negative b over 2a to find the vertex. You heard of that before? Yep, that works. I'm going to show you how to complete the square because it's nice to just shift parabolas. So that's my favorite way. So we have negative x squared plus 4x plus 1. We completed the square earlier this semester as well, right? You didn't like it then, but you're not, so maybe you won't like it as much now. So negative, take out the negative from the x terms. So what number do you add inside those parentheses?
Negative 4 divided by 2 is negative 2, so negative 2 times negative 2 is positive 4.
Yep, do you guys get his logic there? The number that you add is half this squared. And you always add it because even though it's a negative number, when you square it, you get a positive, right? That's, okay. Now you have to put something else on the other end to compensate for what you just did because you have to effectively have added 0. So you've added 4 in parentheses, but there's a negative outside of them, so effectively you've actually added in negative 4, so this should be, you do the opposite, okay? That's a clever trick.
And you're adding 4 because of that negative sign?
Yes, yep. You could also think that you added negative 4 to the right side of the equation, so you must also add negative 4 to the left side. And then when that negative 4 gets moved over, it becomes positive 4. That's one way to think about it as well. And then you should be able to factor this so that it graphs all pretty. So this will be negative the quantity x minus 2 squared plus 5. Do you understand why it's called completing the square? Because you add a number in and you get something squared every time. That's why you add a number in to complete it. That's not the only way. So if you have a different way and you can do it accurately, I don't care if you use it. So now how does this shift your basic parabola? To be
Flip it
upside down, and then it goes that way too, right? Which is right, and
2, and then up 5.
So the basic, so over 1, 2, 1, 2, 3, 4, 5. And then I think the next point will be down 1 over 1 from there. How far is it from those second points to the next points in your parabola? How many spaces? You could count it out in that first one we have. I think it's 4 from the original, right? 1, 2, 3, 4, and over 2. Okay. So we're looking for this area. So what are the bounds on the integral?
0 and 3.
Notice that because we're using x's in our integrand, we use x's in the bounds. Later on today, we're going to use y's in the integrands, we'll use y's in the bounds. Okay, who's the upper curve? Yep. Negative x squared plus 4x plus 1. Why did I choose to use that one and not the next one?
Because that one's got one number.
So the argument is that because I'm trying to torture myself, minus x plus 1. I think it just is easier because you can then combine like terms and stuff. Does that make sense? Okay. Be very careful with the parentheses on the second thing. Do you understand why?
Yeah.
Because that negative is going to distribute. So you have the integral from 0 to 3, negative x squared plus 3x. Once you simplify, the ones will cancel. All right, what's the antiderivative of negative x squared? Negative 1/3 x cubed, plus 3 halves x squared, evaluated from 0 to 3, which is negative 1/3 times 27, plus 3 halves times 9, minus 0. So what, negative 18 plus 27 halves? Did I do that right? I did not do that right. No, I don't know why. I was just testing you again. I do that all the time, don't I? Yeah.
You can have negative 18 over 2.
Yes, I could. Oh, that would actually be, that was what I meant. I was being really helpful. Negative 18 over 2. Exactly. Which is also negative 9. That was not what I meant to do. I just was a boo-boo. So I think that ends up being 9 halves. Do you guys agree? You could, yeah, WebAssign will be totally cool if you give it 4.5, but don't give it 4.5 as a mixed number. Yeah, okay. It will. I won't dock you for that, but WebAssign thinks you mean 4 times a half, which is 2, as opposed to 4 plus 1/2, which is 4.5, right? Okay. All right. So now we had a great question about, well, what happens if which one is the upper curve changes someplace, right? That was the question. Okay. So let's draw a picture of something that does that. Yeah, which is the next example. Oh, goody. So there's my f of x curve. Here's my g of x curve. And suppose I asked you for the area between this a value and that b value. And somewhere in the middle, which curve is above changes. What do you think you have to do? Mm-hmm. Yep, split into 2. Or if there was more than one intersection point, you split it into 3 pieces, right? So if you're going to split it into 2, what do you have to find? So find the point of intersection, which we're just going to call some number c, okay? Does that make sense? Just pick a letter for it. So in this case, the area will be the integral from a to c, and on that first interval, which curve's on top? So we'll do f of x minus g of x there. Dx. Plus the next integral goes from what value to what value? C to B, thank you, yep. And for that, you have to do g of x minus f of x.
Do we have to flip that one because of the alphabetical order?
No, there's no alphabetical order thing.
Okay.
Nope. You have to just, when you are finding an area between curves, the first curve that you use has to be the curve that is greater than the second curve. And so it's just that somewhere in the middle, that role changes. And you have to identify that happens, figure out what the middle point is, and then evaluate both of those integrals. They're going to be similar, but they might not be the exact same. Okay? And a good candidate is sine and cosine, which is what the next example is. Okay, so sine, cosine, 0 to pi. You do have to know how to give me a basic sketch of sine and cosine, and just doing this is not good enough. Okay? So, that's like, I wouldn't even let my Algebra 2 students give me that. Those of you that had me in algebra 2 know that that's true. So.
You gotta draw the X and Y axes.
You've got to draw the X and Y axes, you've got to actually put the like sine and cosines intersect in the right places and give me some semblance of labels. So I only care about 0 to pi, but let's graph them all the way to 2 pi just in case you have to do that. Everything about graphing sines and cosines goes back to the unit circle. And if you feel like it, Wikipedia has a nice little thing where they show you a little dot going around the unit circle and the corresponding graph being drawn. It's kind of cool. So you should go look that up. What are the coordinates of that first point on the unit circle? 1, 0. So let's graph sine first. Yeah, sine is which value in those points? It's the y, so it's 0. Sine of 0 is 0. Pi halves is this angle up there. That's the point 0, 1. So sine is 1. By pi, sine's back at 0. 3 pi halves, we're at this point down there, which is 0, -1. So it's -1. By 2 pi, you're back at 0. So there's one period of the sine function. Okay, and there are also kind of 5 important points there, right? All right, how about the next one? So cosines all the x's. Starts at 1. Pi halves are at? By pi we're at -1, right? Back at 0 by 3 pi halves, back at 1 by 2 pi. Yeah, but definitely it isn't because the parabolas keep going up, whereas this kind of like curves down and levels off. So we're looking for this area, right? And there's an intersection point in the middle. So when does sine equal cosine? At, what'd you say, sorry? I just couldn't hear you. Pi fourths. The other kicker is looking at your graph, you know that point's between 0 and pi halves? Because that also happens at 5 pi fourths, right? But 5 pi fourths is not the one we're looking at. We're looking at the one that's pi quarters. Okay. Alrighty. So then tell me we'll have 2 integrals. So the first one is an integral from 0 to pi quarters. What curve is on top, and what curve's a greater initially? Cosine. And then what curve is below? Sine. Okay. Pi quarters to, what's the rightmost bound? Pi. And in that case, who's the greater curve? Sine, yep, minus cosine. If you're ever on a test and you do this and you get an answer that makes no sense, don't erase all your work because what probably is going to happen is a mistake in the middle. Yes?
So if we didn't want to draw the graphs, we could just find the endpoints and plug in a value in between those endpoints.
The value that's in between has to be the point of intersection. As in this pi quarters is that intersection point.
I set the 2 functions equal to each other, I find where they intersect. Just plug a point in between those 2 points in, and that point is going to give me a higher value than the other function.
Oh, so you're just like checking that way. You could do it that way. I don't think that's actually more efficient. And we're definitely going to ask you to sketch the visuals. So yeah, unfortunately, even though that you can do that, whatever you want in your web assign, I don't care. But for your like take-home quizzes, I want to see the pictures. Okay, so now we do antiderivatives and stuff. So what's the antiderivative of cosine? I think it's just sine. So I think this is sine plus cosine, but check by differentiation, is that correct? Sine's derivative is cosine, cosine's is negative sine, right? Okay, so there you go. That from 0 to pi quarters. Plus, what's this next one going to be? negative cosine, and then minus sine, right? From pi quarters to pi.
Bet you can't cancel them.
Nope, and you cannot cancel them out, I know, I wish you could. Okay, so first you plug in pi quarters. What's sine of pi quarters? What's cosine of pi quarters? That's like the second easiest one I can give you, right? Minus, then plugging in 0, what's sine of 0? 0, cosine 0 is 1. Okay, so there's the first one. Plus, in this next one, first you plug in pi. So we have negative, negative 1. Do you buy that?
Why are we plugging in that first?
Because pi is the upper bound. When you evaluate integrals, you plug in the upper bound minus the lower bound. That's how this works, right? Same thing, we plug in pi quarters first, yes?
Oh yeah, that's right.
Okay. Minus sine of pi, which is 0, minus parenthesis, negative root 2 over 2, and another negative root 2 over 2. Do you guys agree with those steps? If you can be faster with negatives, that's totally fine.
So wait, does that now cancel them?
Well, I think you should be careful because people make mistakes in this problem all the time because they're not careful. So what's root 2 over 2 plus root 2 over 2? Root 2. Then we have minus 1, plus 1, minus negative root 2, which gives us 2 root 2, exactly. Okay. I have given people permutations of that problem, like where I make it negative sine or negative cosine. It's almost the exact same thing. It's just that the graphs are flipped somehow. And inevitably, somebody always gets an answer of 0, and they're like, oh my gosh, obviously that's wrong, because they make some stupid error in the negative signs, which is why you shouldn't rush. Okay. All right, set up, but don't solve an expression that gives the area between the curves 8 minus x squared, y equals x squared, and the vertical lines x equals negative 3 and x equals 3. Okay, so you guys have a grid, I don't, so I'm going to suffer through not having one. What does the parabola 8 minus x squared look like?
Vertex at 8, 0, 0, 8, and then it's a negative parabola.
Yep, so right there, that's one above the grid that you have on your paper. And then it goes through 1, 7, and 2, 4, right?
Then 3, -1.
Oh yeah, well yeah, 3, -1 as well, sure. Choo. Look at that, got that. Okay. Y equals x squared goes through 0, 0, 1, 1, and 2, 4. Do you guys agree with that? That the intersection points here are x equals plus or minus 2? Yes, nod. Yes, okay, great. Now, some meanie pants gave you x equals -3 and x equals +3, which are outside of those intersection points, right? So what we're really looking at is the area from here, in there, and over there. Looks like a spaceship. A little bit? Looks like a pain in the butt, doesn't it? Okay, so, if you aren't clever, how many, and I'm not trying to insult anybody here at all, that came up wrong. If you don't use symmetry, how many integrals do you have to do? 3. Do you understand what I mean by use symmetry? As in, like, this is obviously, if you do the area from 0 to 3, it's the same as, twice that is the same as -3 to 3, right? Okay. So we're going to use symmetry when appropriate, which is now. Okay, so we're going to find the area is twice. So just this part first. obviously begin at 0. Where would that integral end? 2. Because there's that intersection point at 2. Which curve is the upper curve? Which curve is the lower curve? X squared plus, where does your next integral go between? 2 and 3. And in that case, your upper curve is the purple one, right? Which in this case is x squared minus the quantity. If you're going to make a mistake, it's going to be parentheses forgetting. Do you agree with that? It's a commonplace make a mistake. So that's 2 times the integral from 0 to 8. 8 minus 2x squared. Oh, yeah, 0 to cube root of 8. 0 to 2, thanks. Plus the integral from 2 to 3, and what's inside that integrand? 2x squared minus 8. And actually, one more thing, then I'll stop. It is a little bit simpler if you take out greatest common factors from integrals, right? Does that make sense? Like smaller numbers to work with? So you could theoretically make this into 4 times the integral from 0 to 2, 4 minus x squared dx, plus the integral from 2 to 3, x squared minus 4 dx. Do you agree with that? Okay, if you do all the arithmetic, which I believe that most of you could do, everybody makes mistakes and stuff like this. You get, I need 2/3. But you're integrating polynomials, that shouldn't be very hard. Because the level of tedium is rather high in some stuff like this, on the quizzes you're going to take, you will have questions that say set up, don't solve, as in like, this is the answer and that's all I want you to do. You will not get extra credit for going farther, okay? Every time we do that, the directions are gonna be bolded and in all caps. We'll see if I can successfully have nobody actually start solving those problems, but, okay. So is everyone all right with how to deal with curves when you have intersection points in the middle? Okay. What's one reason to graph them too is to watch out to see if there are any of those. Yes?
Okay, so it's not counted as setup until you get either the second or the third expression.
Yeah, and really, if I say set up and don't say simplify your integrands, the first thing is totally correct.
Okay.
I just wanted to get you guys as to the stage at which you would be most likely to get it right. Does that make sense?
Yeah.
Like, because you'll do some homework questions like this, and I think you're most likely to get it right if you simplify it to this stage and then integrate. So that's all I was saying.
If we decided to be inefficient and give you the 3 integrands, we could still do that.
And that would still be correct. Yep, exactly, because it says set up. It doesn't say it has to be the most efficient or the best way, it just says set one up. Yep. Okay. Now, what if your world is sideways? What if you have sideways curves? So, yep. So I have some x equals f of y, and I have some other curve x equals g of y. So in this universe, this is a sideways universe, and I care about some c value to some d value.
Haven't we violated the rule if you can't do that?
No, you haven't. Those graphs are not functions of x, but they're functions of y. So it's totally fine, and you can always graph stuff. It just doesn't pass the vertical line as it isn't a function, but it's still graphable. But think, so in the other integral, in our bounds, it was lesser x to bigger x, right? So in this case, the lesser y is the lower y. Does that make sense? So that's c to d. With the x, universe, it was top minus bottom, right? The top curve was the one that was the bigger number, yes? As in the y value was bigger. This one, who's bigger?
Bigger x.
F of y minus g of y. think about that as rightmost minus leftmost. Well, you think your little rectangles go sideways, right? This x value is bigger than that x value. If you just turn your head sideways and like look at it, you're like, oh yeah, that one's on top. Yes?
Could we just put the x and y coordinates and do it like before?
Yes. I don't like when people do that because I feel like they should know how to graph sideways curves for certain stuff. And we'll do things later on where it's just not going to be efficient to do stuff that way. So if you want to use it to check your answers, sure. I have to powwow with Professor Fodry to see what we'll do if you do that on a test. Does that make sense? Like, let me plead the fifth on that for now.
Right.
All right. So try to graph them with y's because it's good to kind of just see if you can make it happen. Also, does anybody have a Mac? A Mac computer or iPhone? There's a little app called Grapher. It's pretty helpful. And there's also graphing apps on the iPhone of a Mac. But if you type in the Grapher, x equals like sine of y, it will graph that sideways curve for you. It's pretty cool. And it doesn't require any kind of specialness. Like, you just type Grapher in your little finder and you'll find it and it works great. So, all right. Oh man. The line y equals x minus 1 and the sideways parabola y squared equals 2x plus 6. Okay, whew. Well, I can graph the line easily, right? That starts at -1. And it rises 1, runs 1. Okay. How can you tell that that parabola is going to be sideways? It's y squared, yep. How about we solve it for x? Does that make sense? So x, 2x will equal y squared minus 6, right? Does that make sense? So x is equal to half y squared minus 3. Okay. And maybe you're rusty on graphing sideways parabolas. So let's just go back to your default method, fallback, which is to make a table and plot points, right? That's always your fallback method for graphing, and you can pick whatever numbers you want. And this time, usually you pick x, you find y, right? Here you're gonna pick y, find x. So if y is 0, x is -3. I don't want to choose y equals 1 because I don't want to deal with fractions and I'm being lazy. So let's pick y equals 2. So 2 squared is 4, half of 4 is 2, 2 minus 3 is -1. Do you agree? What if I pick -2 for y? You get positive. Do you think you get -1 again? Right? Yep, okay. So let's graph those points. So -3, 0, -1, 2, -1. So I got one intersection point, right? You agree with that? Okay, what one last number, cleverly choose it. Which one do you think you want to pick? 4. We already picked 0. If you pick 4, 4 squared is 16. Half of 16 is 8. 8 minus 3 is 5. So over 5, up 1, 2, 3. Oh, look at that. Alrighty. Gesundheit. So when you do sideways integrals, the values that are in your bounds should be the y values. So what is the y coordinate of that lowest point of intersection? -2. What is the y coordinate of the upper point of intersection? 4. And then you need to do rightmost minus leftmost. Who is the rightmost curve? The line. But what do you have to do to plug it in?
Solve for y plus 2x.
Yep, solve for x. X equals y plus 1.
That would put dy.
Exactly. You put dy. And the idea is you kind of did these sideways box things. So there was, instead of it being change in x, it was change in y. But yeah, if you make a substitution, if you flip-flop x and y and graph it normally, you're going to get the exact same picture and the exact same intersection points. I mean, it's not going to be wrong. It's just, yeah. So,
Just nothing to practice and rolling over.
yeah. So integral from -2 to 4, we got -1/2 y squared plus y plus 4. Do you guys agree with my simplification? Okay. Because we're going to run out of time otherwise. I'm just going to say dot, dot, dot. This eventually becomes 18. If you feel like you want to do more studying and you actually do the practice problems that I suggest at the bottom of these note sheets, it is totally fine to do something like set them up and then use Wolfram Alpha to check your answers, because the most hardest thing is the setup. Don't waste your time doing lots of arithmetic. Does that make sense? Okay. Alrighty. All right, let's just set this one up and then we'll move on to the last page. So and these should be easy curves. What does 1 minus y squared look like, and what does y squared minus 1? These you can kind of do with transformations. So x equals y squared is kind of like a basic sideways parabola. We just draw it in like dotted. So the easier one to graph is y squared minus 1. How would that be shifted? Left, right, up, down?
To the left,
To the left, how much?
1 unit.
1 unit. You could verify this by just plugging in some numbers. If you plug in 0 for y, you get x is -1, right?
Wait, they count as
What will this one look like? What will the negative do? We'll take the x's that were positive and it'll make them negative, which flips it over the y-axis, right? And then it moves forwards 1, yes? Because this is a positive 1. You could think about it as -y squared plus 1, right? And of course, these things can all be verified by just plugging in some numbers. If you're uncertain, that's totally a fine method. So there's your area. Whether or not you graph stuff like that in a previous class, like Algebra 2, depends on your teacher. Like, I knew my students had to know it, so I made up a worksheet and made them do it, but other books didn't do stuff like that. So can I use symmetry here? Yep. So I can do twice the integral from 0 to, what is that y value there? 1. And who's the upper curve? Yep, so the 1 minus y squared, minus the lower curve is y squared minus 1, which gives you twice integral 0 to 1. I think that's 2 minus 2y squared. Do you guys agree? Or 4 times integral 0 to 1, 1 minus y squared. Could you get it from there if you had to? Probably. You should get, if you want to work it out later, dot, 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 you get 8/3. Okay. And next we have some application questions. And they're not necessarily all that much harder. So here you have some velocity curves for two cars. The cars start side by side and they move along the same road. What does the area in between these two curves represent? How badly A is toasting B? Yes, pretty much. So the integral from 0 to 16 of A of x dx, that's the distance car A travels, right? That makes sense? The integral from 0 to 16 of B of x dx, that's the distance car B travels, right? So it's the difference between them, yep. So the area between the curves.
Come on, you don't know that A is toasting B?
Yes, you do.
Yes, you do.
Yes, you do, because A has a higher velocity than B, so A is faster than B.
I think he's talking about
Well,
the
maybe they
position.
put B like 100 meters ahead of A.
No, they
Except they start side by
side.
Yeah.
You're right, that if you didn't know this, you couldn't actually determine that, right?
Yeah.
But you could say the area between the curves is the distance traveled by car A and not by car B, or the difference in distances, right? But in this case, is the distance between the cars.
There's no way they're drag racing, they're topping out at 6.
This
This is getting up to the high.
Yeah, yes, it definitely is. Yeah, we're not drag racing, we're just accelerating. Yep, up to 60. So it tells you, how much, so just, it's the distance between the cars, or it's how much farther, how much farther car A has traveled. Thank goodness we're not making you actually estimate it, because this question was silly and the axes have different units. That's a problem, right? If you wanted to actually find that area of the curve using the boxes, these things need to be the same units. But the question just asks to interpret it, not to find it. The WebAssign question gives you a picture and it says something like, which one makes the most sense out of these 4 choices? You have 5 chances to get that question right. Nobody better miss those, guys, okay?
No, I insist that this one that he keeps telling me is the right one, so I'm just going to click it over and over again.
Yes, exactly. All right, so here another example. If the birth rate of a population is given by B of t equals 2,200 e to the -0.42 t, and the death rate is 1,460 e to the stuff, find the area between these curves. So can you tell me so when you plug in 0, which curve is above? B is higher, right? B is at about 2,220 when you plug in 0, and then it increases exponentially. D, so that's B of t. D, when you plug in 0, gives you 1,460, right? How do you know that D is always below B? Say that again?
Is it just 2,200?
It's 2,200, yes, that I added an extra 2. The powers, yeah. The rate of growth is the percent growth per year is 2.4% versus 1.8%. The rate of growth is higher in B. So you know that B is always above D. Okay?
Well, if you're talking about Japan, you might want to swap the graphs around.
Well, if you're talking about Japan, then there would be different equations. Yes. Yep, because Japan's death rate is greater than its birth rate. Yes.
That might be a good thing.
Yeah, it is, but, well, wait, I didn't have an opinion. 0 to 10, recorded it, crap.
I was doing in order to die. I was saying that overpopulation is a problem.
I understand. Okay. So, 2,200 e to the 0.024 t minus 1460 e to the 0.018 t. I'd like you to give me your antiderivatives, and after that stage, you can plug into a calculator and get your answer, okay? But at least giving me an antiderivative shouldn't be something that's impossible without a calculator. Because what's the antiderivative of e to the 3x? 1/3.
Yes.
So can you generalize that to this stuff?
Mm-hmm.
2,200 over 0.024 e to the 0.024t, right? Minus 1460 over 0.018 e to the 0.018t. And at this stage, definitely use technology. You get approximately 8,867.99, which, since we're talking about people, it makes sense to round to the nearest whole number. So that's about equal to 8,868.
Maybe that last guy isn't just about.
Shh, nope. That's not what that 0.99 means.
What if you lost one?
Guys, shh. I do have one question to get to, so please. What does this area represent?
The increase in population.
Perfect, the increase in population. Do you guys agree with that? The area under the first curve is how many people were added. The second curve is how many people were taken away, and you subtracted those, right? So it's the increase in population. And that was over
10 years.
10 years. Okay, great. The AP test loves questions like that. Yes?
Yes.
Okay, one last question. Find the value of C such that the area of the region bounded by y equals x squared minus c squared and c squared minus x squared is 576. And you're like, what? A little bit like what? No, not so bad? Okay, well,
No, you just put 576 for A.
there's no A. Oh, yes, there is. You'd put for A, sure. But roughly speaking, what do those graphs look like? What does x squared minus c squared look like? It's a shifted down c squared, right? Do you buy that?
Yeah.
Okay. So, okay. What does the other parabola look like?
Shifted up, C squared, then down.
Uh-huh. And this is on purpose. They are going to intersect at the axis there. So let's find those intersection points. It's at C. Do you guys agree with that? X squared minus c squared equals c squared minus x squared. So 2x squared equals 2c squared. Pretty obviously there, x has to equal plus or minus c. Okay? All right, great. So we know that this area is 576. So integral, and we're going to eventually make it equal to 576 and solve, okay? So A equals, can you use symmetry? Yes. So we'll do twice the integral from 0 to c. Who's the upper curve? The lower curve is x squared minus c squared. It's 2 2c squared minus 2x squared dx. And then let's take out that 2 and say 4 integral 0 to c, c squared minus x squared dx. Is everyone okay to that stage? Yeah, okay, yes.
Couldn't you then say that no matter what happens, whatever you put in for C, when you put that in, you're actually going to get 0?
No. Let me finish, then you can ask, all right? So, is C a constant or a variable? It's a constant. So that when people make mistakes in this question, is in the next step. When you anti-differentiate c squared, which is a constant, what do you get? C squared x, or xc squared, not c cubed over 3, okay? The dx is the thing that tells you that, oh yeah, c is a constant.
How do you know that C is a constant?
I mean, it's not changing, right? They really should state it in the problem, but the thing is your textbook does not do that. So it is the case almost always that A, B, and C's are constants, almost universally in this textbook. and that x and y and z and things like that are variables.
Okay.
Or k is almost always a constant as well. Yep.
Is
And-
it possible to have?
And also, can Mary Kate, the other way to tell is that the dx, like the dx tells you what the variable is. You will deal with things in Calc 3 where you have multiple variables like x, y, and z, and then there's other stuff that happens. Minus x cubed over 3. Okay, and then plug in your stuff. You get 4 times c cubed minus c cubed over 3. Do you agree with that? So that's like a whole c cubed minus a third of a c cubed, which is how many c cubes? 2/3? Do you buy that? Okay, so 4 times 2/3 c cubed is 8/3 c cubed.
Oh, and then you set that equal.
And then you set this thing equal to 576. And you end up with c cubed equals 216, and you get c is equal to 6. That is not a cube root that I knew by heart until I did this problem.